Hello learner, welcome again to Manifested Online Classes. My name is James Kenyani. We are going to have one of the winding lessons on similarity and enlargement, and that is application of the knowledge of linear scale factor, area scale factor, and volume scale factor. So as the lesson is application of linear scale factor, area scale factor, and volume scale factor. So the objective of these is to enable the learner to be able to solve problems by using those scale factors. So as the objective goes is to enable the learner to solve problems using the above named scale factors. And as usual in these, we shall look at an example that gives you a wider view of that. So there is example 1. There is an example there. Example 1. It goes. So there goes the question. We go through it again. Two similar jars are such that the height of one is 3 times the height of the other. The smaller jar has a surface area of 27 centimeters squared and a volume of 6 cubic centimeters lana. What are the area and the volume of the larger jar? So we come to the solution. We have the smaller jar. Larger jar. So there is a relationship given there. The relationship given there of the height. When you hear of a height, that is a linear scale factor. So the ratios of the height is h to 3h. So if you hear of a height, learner, that is linear. That is linear. So you can simply come and say when height would refer to linear. So the linear scale factor learner, when comparing the jars, will be h to 3h. The h and the h cancel, and you have 1 to 3. 1 to 3. So when you have that from the ratio, the linear scale factor will be 3. When you are comparing the two jars, the linear scale factor will be 3. The area scale factor as we learned earlier will be equal to linear scale factor squared. Linear scale factor squared, which will be 3 squared. 3 squared. And learner, the volume scale factor will be equal to the linear scale factor cubed, as we learned in the other lessons. Cubed. That will be 3 cubed. That gives me 9, and that one gives you 27. So you'll go to what they have asked you. What are the area? So you'll come and say 1, area of the larger jar area of the larger jar will be given by area of the smaller jar multiplied by the area scale factor. Multiplied by the area scale factor, which I've got from that. So it will be the area of the smaller jar was 27. I was given. So I'll come and say 27 square centimeters times 9, which is the area scale factor. So on multiplying, 9 times 7, 3 carry 6. 9 times 2, 18. 18 plus 6, 24. So that is my area. Secondly, I have the volume. I have to get the volume. Volume of the larger jar. Volume of the larger jar. This will be equal to the area volume of the smaller jar, which was given. The volume of the smaller jar multiplied by the volume scale factor. Volume scale factor. Area, so sorry for this. Oh, this is correct. Volume scale factor, which we got as 27. So you'll come and say 6 cubic centimeters times 27, and your answer works to 7 times 6 is 42. I'll carry 4. 6 times 2 is 12. 12 plus 4 is 18. 18. Volume is given in cubic units. So that gives me, learner, the volume of that. You've seen how we've gone through that solution. When they are comparing heights, they are comparing linear measurements. So that gives us the linear scale factor from that ratio, meaning this one has a height 3 times the smaller jar. We look at the second example as we wind up. So that's the question, learner. Let's go through it. The area of an island on a map. These are the applications I was talking about initially in the past lessons. The application, the area. What is the area? The area of an island on a map drawn to a scale of 1:100. 1 unit on the map represents 100,000 units on ground, is 300 square centimeters on the map. What is the actual area of the island on ground? What would be the area of the island on a map drawn to that scale? So we move to the solutions. the solution. And we start with A. Start with A. So you realize, given a scale of 1 is to 100,000. Some people would write it as a representative fraction of 1 over 100,000 as a representative fraction. It is equivalent to having that. It means the actual sizes on ground are 100,000 bigger than what you see on the map. So it means the image you'll get on the map, it has to be transformed 100,000 times to get the actual image. And that actually gives us the linear scale factor. From these, the linear scale factor is 100. $100,000. And from there, the area scale factor will be equal to linear scale factor squared. Linear scale factor squared from what we have just got from a previous question. So it will be 100,000 times 100,000. Those are centimeters. Those are centimeters. So we come to actual area of island. I'm interested now in the actual area of the island learner. So I'll take will be equal to area of island on map times the area scale factor. Area scale factor. The area scale factor. So the area on the map is 300,000. This is 300,000. 300 square centimeters as given, not 300,000, times the area scale factor, 100,000 times 100,000. This will give you square centimeters. This will give you square centimeters. That will give you square centimeters. You'd want, if they'd asked you to find in kilometers squared, so you'll have to work 1 kilometer squared. 1 kilometer squared. 1 meter is 100. 100. 1 kilometer squared is actually equal to 100,000 times 100,000 centimeters squared. Because 1 kilometer is 100,000 centimeters. So kilometer. So you'll come in kilometer squared if they had asked you. But you can end the answer here. It will still be correct, but in kilometers squared, it will be 300,000, 300 times 100,000 times 100,000 divided by times 100,000. That is if you are to work in kilometers squared. This will cancel this and it remain with 300 kilometer squared. So that would be the area of the island on ground. We move to B. What would be the area of the island on a map drawn to? What will be the area of the island on the map drawn to that scales? What will be the area of the island on the map? If the scale, you can just, if the scale is that, so you can just leave in that to make it the understanding easier. Now, when we compare B, drawn to on a map of scale 1:50,000, 1:50,000, the map would be bigger. The map would be bigger. Can you ask me if somebody asks you why? Here we have one representing 100,000, but we now have one representing 50,000. So this map would look bigger. So we shall comparing linear scale factors. You'll compare the first one, which was drawn to this map, and the other one. So it will be 100,000 to 50,000. 100 to 50,000. So that will be 2 to 1. So we discover the linear scale factor. The linear scale factor, when we are comparing the first map and the second map, is 2. So I've said the same map drawn to a scale of 1 to 100 and another one drawn to a scale of 150. That one drawn to a scale of 150 would look bigger because one part is representing 50,000 here, and here it is more fractionalized. It is made much smaller, so that one will be bigger, and therefore the area scale factor, and therefore the area scale factor will be equal to the linear scale factor squared when you are comparing the maps. It's like we have in the other lessons we are using a cuboid, 2 cuboids. Here we are using the first map and the second map. So if it is just a figurative, you'll have map 1, map 2. Map 2 will look bigger. Map 2. So you are comparing the two in terms of linear ratios. In terms of linear ratio. So the one you draw to this, comparing this map will be bigger. This one is drawn to 1 to 50,000. This is 1 to 100,000. This is much fractionalized, made much smaller. So this will be equal to 2 squared, which is 4. So if they had an area here, this was the island. In this second map, the island would now look bigger. So we'll come and say area on this second map will be equal to, you'll take the area on the first map, which was given, area on the first map, multiplied by area scale factor. Area scale factor. And I've got it from the relationships of the linear. This is measurements, linear. So if this one is drawn to that, you see the comparison. So be careful. Don't look that this one is small, a smaller number that it will give a bigger mark. It is opposite. It is inversely proportional. The smaller this number, the bigger the map. The bigger that number, the smaller the map. So you'll come, area on the map was given us 300 centimeters squared times area scale factor, which is 4. So that will now become 1,200 square centimeters. So just a recap of what we've done in that. Where did we start? We started with the linear scale factors. What is the actual area of the island on ground? So we got the linear scale factor and we get the area scale factor. So the actual area is area on the map times the area scale factor. So I said you would have just ended here. It's a very big number, but usually we break it to kilometers so that you reduce those zeros. And we found 1 kilometer is 100,000 times 100,000 square centimeters. So that gave the solution. When we came to the second, they are now saying this map is now drawn to this scale. From our discovery, the bigger it is an inverse proportionality. The smaller that number, the bigger the map. The bigger that number, the smaller the map. So that will be assignment learner from Mathematics for Kenya Schools by Patel, page 101. So sorry. Exercise 7.3. Page 100 and 101. Page 100 and 101, numbers 8 to number 18. So thank you very much for the audience you've given me throughout that topic, and I hope as we finish the application, you are going to apply it even on maps outside in other related areas of life. So thank you very much. Work through the solution, enjoy going through, and let's meet again on this platform. Thank you very much.